Here we go. All right. Okay, let me just make sure. Okay, so we have this correspondence diagram. Here, I want everyone to actually try drawing one. So let me actually stop the recording. So here, let me say it again. There's more than one right answer here, okay? So what I'm going to show you might be different than what you have, but that's okay. There's nothing wrong with that. This is one example. I mean, you could have drawn what we saw earlier. What I drew was this. Well, not draw it, I guess. I used the computer. But here, right, I have 1 to 6. So if 1 is our input, 6 is our output, right? 2 is our input, 8 is our output. 3 is our input, 2 is our output. 4 is our input, 4 is the output, okay? So again, we do have a function here. And how do we know that? Mostly because from each element in the first set, there's only one arrow coming out of it. There's only one arrow coming out of it. Again, the function you could think of as, I guess, how do I say it? All these, what do you call it? Arrows here. Remember, they're straight, so it's not going to bend, you know, like something like that. Okay. Here's another example of a function. I know some of you are thinking, that's a function? Well, yes, it is. Yes, this is a function. Okay, again, you only have one arrow coming out of each domain element, as you can see. Okay, in other words, we have a function for each input is assigned one output. I mean, each of the inputs here, they're each assigned to the same output from Y. So they're each assigned the same thing from Y. That's okay. That can happen in a function. That can happen. Not to mention also, from each input, you only have one arrow coming out of it. So, you know, from 1, you don't have, let me see if I can get back to it. You don't have this, in other words. Okay? This is not a function because 1, an input has different outputs. Here, you have different inputs have the same output. That's fun. Okay. So we have that. Are there any questions at all? Remember, I can't see the chat, so if you have a question, you know, use the, what do you call it, the hand raise feature. Then type in the chat if you want. Okay. Now, so again, this is what I was saying before. We do have one way to make a function, right? I mean, whenever you make or define a function, you have to somehow set up that rule that fits the definition we saw. You know, you can make up a rule somehow, but it has to satisfy the requirements or conditions, if you want, of that definition. And there's many ways of defining a function. You know, one way is using correspondence diagrams, right? We saw you can't just draw a correspondence diagram any way you feel like it, right? You have to draw it in different ways. Excuse me, you have to draw it the right way, as we saw. If you draw it the right way, then you have a function. I just put the definition here of what a set is, at least in this class. This class meaning Math 104. So for my other section, it's the same thing. Another way to define a function is using a relation. Okay? A wonderful relation. A relation by definition, a relation by definition is a set of ordered pairs. So it's a collection of ordered pairs of numbers. So this would be a relation. And so would this. These are both relations. And you'll see that through a relation, we can define a function. In fact, what's going to happen is you'll see, not on the next slide, but from a relation, you can actually make a correspondence diagram. And you can go the other way around. But anyway, in a relation, you can have domains and you can have the range. So a relation alone can have a domain and a range. The domain of a relation is the collection of all the x coordinates. It's the collection of all the x coordinates, as you can see, all of them. Okay? The range is the collection or the set of all the y coordinates. The range is the set of all y coordinates. So in this example here, the domain, would be 1 and 3. You don't list an element more than once in a set. I mean, if you happen to do that on a test or something, I'm not going to take off points, but you want to make sure you don't do that, though. The range would be 4, 2, and 9. Yeah. The domain of this one, as you can see, would be -2, 0, and 1, right? Or 1, 0. I wrote it this way, but really with a set, I don't know if I said this before, but the order doesn't matter, the set. Again, it's all the x coordinates, as you can see. And the range is all the y coordinates. So we have 1, 0, and 5. Okay. All right. Now, as I said before, we can actually, there is a connection between correspondence diagrams and relations. There is a connection. Namely, if you have, as you see here, an ordered pair A, like from a relation, let's say, then you can actually make a correspondence diagram and draw an arrow from A to B, like so. So from the idea is that you would have to do this for each ordered pair in the relation. You could do this for each ordered pair, okay? So from each ordered pair, you would have basically a correspondence. In the correspondence diagram, you would have an arrow from the x coordinate to the y coordinate. Now, you could also go the other way around. Namely, if I give you a correspondence diagram, you can make a relation out of it. Essentially, if you have this, you would go this way. From here, you would go to the ordered pair, and then you would get to the relation. Okay. In fact, here's this example. We can actually go from this relation to this correspondence diagram, right? You can see that here's this relation. Here's the ordered pair 1, 3. Okay, so we draw the arrow. From 2, 4, we draw the arrow. What, from 2 to 4? From this one, we have 4 to 6. As you can see, 4 to 6. Now, So we have from this relation, this correspondence diagram. I mean, I know I didn't put it on the slide here, but you can actually think about going the other way around. You could think about as if, let's say the relation was not written. I gave you this correspondence diagram, but you can get the relation from that. From the arrow, you get the ordered pair, 1, 3. Here you get 2, 4, and 4, 6. The domain, as you can see, is all the x coordinates. 1, 2, 4, the first set. The range would be 3, 4, and 6. Over here, that's the range, all the y coordinates. Okay. All right, let me pause the recording.